Hello and welcome to Eureka Math Academy USA, where today we're going to discuss linear interpolation. Our specific application today will be March temperature. Here we have a table that shows various values of time and temperature. 10 o'clock, 10:30, and 11, and temperatures 41, 42, and the mystery temperature, what is the temperature at 10:30 a.m.? And that's what we're going to discuss today. First, let's look at the graph. The bold line here is the temperature curve, and we have the 2 points, x naught, f of x naught, and that equals the top values here, 10 o'clock, 41 degrees, x1 and f of x1, which equals 11 a.m. and 42 degrees, and then x comma y, what we want to find out at 10:30. Let's look at some algebra to see how this works. A good algebra book will give you the equation for your linear line as y minus y naught equals m times the quantity of x minus x naught, where m equals delta y over delta x, the slope of the line. Rearranging this equation for y gives y equals y naught plus m times the quantity x minus x naught. And now substituting our variable names in our table, we come up with this equation, which looks kind of unwieldy, but really once we put our values in, it'll make total sense. We call this equation 1. This is the equation of what we call our secant line, the line connecting the 2 points in the table above and interpolating the value that we want to find out. Now all that's left to do is to plug in our values from the table to get this equation, and then when we solve that with a calculator, it's easier. We come up with y equals 41.5 degrees. This equals our question mark, 41.5 degrees, and that's the temperature. One last point, you can see that this value is less than the actual value on the temperature curve at f of x naught. See, the temperature curve is here, but the value we found is right here. That's because this is just a linear interpolation, is actually an approximation that makes it easier to find the values.